All right, let's get the webinar underway so we don't take too much of your day. So welcome to today's webinar. My name is Carlos Silva. As you can see on the slide, I am the country manager for Eastern Europe. My main focuses are in Poland and Hungary. I can see here a lot of the registrants are from Poland. So dzień dobry to all my friends out there in Poland. I'll be taking you, or we will be taking you through the GoodWe energy storage product with a main focus on the three-phase hybrid inverter. And we have a special guest here that we've invited who's been kind enough to join in, and that is Alvaro Garcia. I'll just maybe pass it to Alvaro to maybe do a quick introduction for himself, and then we'll begin the webinar.
Thank you, Carlos. And thank you, GoodWe, for inviting us to participate in this webinar. So I'm a commercial director of EFT Systems. EFT Systems is the service partner of the BYD battery box in Europe. And I'm in charge of all new markets. And quite quickly this year, Poland is going from being a new market to a pretty major market. So I'm quite excited to be here today to present the products that are compatible with GoodWe.
Fantastic. Okay, great. Just a few housekeeping, not rules, but things to take just to note. We do have a Q&A section on your console there. So if you have any questions, please put them there. We'll answer them as we go through the webinar or towards the end of the webinar. At the end, I'll stick around for 5 to 10 minutes to answer any other outstanding questions. This is, I must be clear, this is not a forum. It's not a forum for your after sales support questions. So if you have any problems with your inverters right now or your batteries right now, please contact the GoodWe service team or contact the GoodWe, the BYD service team. So let's get on with the webinar. So you will also get a copy of the presentation after the training, so don't worry. So in terms of what we'll go through on the GoodWe side, I see from a lot of the participants, I see a lot of familiar names from the GoodWe Plus training modules that we have been administering over the last few months. So I think a lot of the content you will already know. So I think you're more here for BYD. Who is our special guest. So I'll try to go quickly over through the GoodWe content as quick as possible and then get onto the BYD section because I'm really interested to see what BYD also has to offer, especially for our friends in Poland. But not only in Poland, we also did invite people from around Europe and around the globe. So we have a melting pot of different cultures and nationalities. So great diversity that we have here in today's webinar. So, but before I go on, I would like to just mention our GoodWe Plus program that you may or may not be aware of. So there are a number of benefits you receive when you become a GoodWe Plus installer. So one of these benefits usually consists of hands-on training. So that's face-to-face training with me or with one of our technical managers. But however, due to the current COVID-19 situation, webinars and online meetings are only possible at the moment. When you become a GoodWe Plus installer, we also offer exclusive after sales and warranty benefits such as a service replacement fee, and we are now offering the long-awaited 10-year warranty for Grid Connect inverters from 700 watts to 20 kilowatts, which I believe is the main attraction. If you'd like to know more about the GoodWe Plus webinar, go onto our GoodWe website. There is a section on our website which tells you the next schedule of the next training sessions. So in order to qualify as a GoodWe Plus installer, you need to have completed the 3 training modules that we run once a month. We do offer them in a different number of languages, such as in Spanish, Italian, English and Dutch, and through our partners in different regions. For example, in Poland, we are also running webinars in Polish as well. So again, just check the website, check the schedule to see when the training sessions are run and register using the links that you can find on the website. So fantastic. A little bit about GoodWe itself. So when we take a step back from the European market, we do begin to see the global presence of GoodWe in many regions of the world. So outside of Europe, we are also present in Asia Pacific. So in Australia, where I'm from, Southeast Asia, Africa, the US, and Latin America. So by virtue of our global spread, we have over 1,600 employees in over 200 in engineering and R&D, who together have developed over 130 patents. And since 2010, we have grown to have over 12 gigawatts of production capacity. So this does give you a sense of the commitment that GoodWe makes when it is entering into new markets, which is an exercise which can generally only take place when you really have an offering of wide portfolio of products. So the team in Europe, where I'm based in, are constantly assisting and providing feedback to our colleagues in headquarters. So it allows us to improve the products, not only in the features, but also in the availability of documentation and helping GoodWe reach the standards that are expected from our European customers like yourself. Here is a slide of our presence in regards to our after-sales support. So we do have a strong focus with after-sales, trying to provide our installers, our customers with enough after-sales support as possible in as many different languages as possible. So as you can see here, we have local service support in a number of countries, which also can speak a number of different languages. So for example, in the Netherlands, we have our after-sales support that can speak Dutch, French, and English. For example, in Germany, we have our after-sales support that can speak in German and English, for example. So if we're looking in particular in Poland, we do have a local GoodWe technical hotline. So that means the installers such as yourself can call the GoodWe hotline and speak to someone in Polish. Most of the local, all the product replacements that we send for any unfortunate failures that happen out in the field will be sent from Poland. And if you become a GoodWe Plus installer, you will be eligible to send us an invoice for the replacement of that replacement inverter. We do have also the capabilities of having someone on site to help you with your problems, but that is in very exceptional circumstances. What is also interesting to note, our service repair center is actually based in Poland. So all of the inverters that fail in the field do get sent to Poland to be refurbished and repaired, and then reintroduced into the refurbished pool of local service inverters. So again, for the details and contact numbers and emails, you can visit our GoodWe website and go into the contact section, and it will show you the service numbers and the service emails. So GoodWe is a string inverter manufacturer with varying levels of power classes from 700 watts to 250 kilowatts now. So this includes grid connect inverters along with our hybrid inverters. So since we entered the market in 2010, we have been steadily growing our portfolio, which has been guided by the trends and the needs of the users such as yourself. And I would say that we were one of the first brands to release a Grid Connect hybrid inverter in 2014. So we've had about 6 years of hybrid experience. And this was generally targeted at single phase markets. So for example, in Australia and in the Netherlands. And so from until that point now, I believe we have built up a substantial amount of knowledge with respect to hybrid inverter design and technology. So not only at the component level, we have also built the necessary technology partnerships, which are built on synergies between ourselves and battery manufacturers, because in particular, in the energy storage market, the launch of a successful hybrid inverter solution requires a significant amount of investment and effort into ensuring that the products are well integrated into a common ecosystem. So it is a common rule that we partner with battery manufacturers who not only provide a quality and reliable solution, but who also provide an after-sales support structure, which provides support for our installers. So for example, BYD has set up a European infrastructure service system by partnering with EFT Systems, where Alvaro Garcia is a colleague of. So who EFT Systems provide on behalf of BYD, pre-sales and after-sales support in many regions throughout Europe. So this level of commitment is crucial in being able to meet the demands of the users. So although, as you can see, sorry, I'm going to just quickly. So as you can see, over the years, GoodWe has been awarded many different awards over since 2015 from two Rhineland, some international reporting agencies, and by the European PD research, we have been given a shield for being the top brand inverters over a number of years, especially in Australia and in the Netherlands as well. And quite recently, Wood Mackenzie has listed us as the world's #1 storage inverter supplier. What I would like to mention as well is that in late 2019, we submitted our inverter products and a BYD battery into the Energy Storage Inspection 2020 program, which is a testing procedure which is led by German Berlin University, which takes the inverter system or the energy storage system through a rigorous program. And at the end of this testing, we are provided a score out of 100. So although we did not achieve first place, we did manage to obtain a respectable score of 90.9, which is, in my opinion, a very good result for our very first submission into this very rigorous testing procedure. Whereas other brands have been submitting their products over the last few years, allowing them to fine-tune their systems, hence giving them an advantage. So you can see that the highest score was 94, and we are not very far away from that. So what I will say is that we are keen to improve, and we will invest significantly for the 2021 tests, where we hope to improve on our 2020 results. So just to give you a bit of context, these scores that you see here is a major marketing influencer with regards to the end users in Germany in particular, where German end users really look towards these SPI scores to determine which energy systems they would like to install in their house. So again, we were one of the only Chinese, we were the only Chinese manufacturer or the only non-European manufacturer of inverter products to actually submit our system through these tests last year. So that's a bit of the marketing and a bit of an introduction of the GoodWe story. What I will do now is go into the concept of battery storage. So the storage market is the next step of the evolution of the PV industry. So for many people who have been working in the industry for 20 years, like myself, it has taken a long time to get to this point where it is becoming an accepted technology. However, there is no doubt in my mind that we will see accelerated growth over the next 1 to 3 years as countries around the world will look to meet their emissions target. So traditionally, grid-connect inverters, as you know, generate power whenever the sun shines. So this power is usually sent to the consumer loads and then into the grid. However, as you can see, the generation profile, which you can see here in the yellow curve, doesn't really match the typical profile of our typical household. Therefore, particularly in the summer months, there will be a lot of export power being exported to the grid. And the value of this power that's being exported to the grid is usually less than the value of the power that is being consumed by the customer. Therefore, by adding a battery to a PV plant, you are able to capture and store this excess energy, which can then be used in the morning and in the afternoon. However, in the winter months, due to the low levels of insulation, there will be not many days when the battery will reach a full state of charge. However, because of the flexibility of hybrid inverters, you can solve this by simply adding more PV panels to the inverter. So our inverters do have a high DC to AC ratio, which allows you to add or connect more PV power with respect to its nominal AC output. Therefore, you can see that the orange curve gets as high as the summer curve in theory. So what is the logic of the operation of a GoodWe hybrid inverter? So if you can imagine yourself as a PV array, so the power that you produce as a PV array will be first used to supply the loads. And if you are producing more power than what is required, then the excess power will then be sent to the battery to charge up to 100%. So when the battery is full and there is still excess power that you are generating, this power will be then fed into the grid. So it's very simple logic of operation aimed to increase your self-consumption. So if you're looking at the logic of operation from the load side perspective, so if you can imagine yourself as a household load or an appliance, you will draw power first from the PV array. If there is not enough power from the PV array, then you will draw the power from the battery. And if there's not enough instantaneous power from the battery, or if the battery is at a low state of charge, you will then draw the balance from the grid. So a very simple logic of operation in the way that our GoodWe inverters work. So before I talk about the products, there are a couple of terms that you will hear quite a lot in the storage segment. So DC coupled and AC coupled. These are not very particularly difficult concepts to grasp, but I will give you a crash course in what they both mean. So in regards to the DC coupled systems, the principle is that both the DC output of the PV array and the battery are connected to a common point on the DC side of the inverter. So that means they are coupled on the DC side, hence the term DC coupled. So in this way, the PV power produced from the PV array can flow directly into the battery without having to be converted from DC to AC and then back to DC. So this topology minimizes the system losses. So we would say that it has a higher round trip efficiency when compared to AC coupled systems. So apart from a higher overall system efficiency, another advantage of a DC coupled system is that when there is a grid failure, in this scenario, if the grid went down during the day, the backup loads will continue to be powered from both the PV and the battery. And that will happen until the sun sets in the evening. So that's one major advantage of a DC coupled system in a backup mode scenario. So in an AC coupled only storage system, the AC coupled inverter is only a DC connection to the battery. As you can see here, there are no DC inputs for the PV panels itself. So the PV power in this system is provided by a standard grid connect inverter, which is connected to the same AC point of connection as the AC coupled inverter. So we typically call this AC coupled inverter a battery inverter because it's only connected to a battery. So you might hear a number of terms being bandied about in the industry, AC coupled inverter or battery inverter. But I tend to think that battery inverter kind of makes more logical sense. So strictly speaking, our AC coupled battery inverter is not a hybrid because it does not have its own direct PV array connection. So therefore, it's generally referred to as a battery inverter. But what is interesting to know, this battery inverter is bidirectional. Therefore, any excess power that is generated by the grid connect inverter will then be able to be fed into the battery bank as well. So if the loads are using half of the PV power that's generated, then half of the PV power will then go back into the battery. And when the battery is full, then the grid connect inverter will then be able to export back into the grid. So this just gives you a quick overview of the advantages and disadvantages of each system. I won't go into too much detail here, but what I would say is one of the main disadvantages of an AC coupled system, especially in a grid failure scenario, is that when the grid is down, the grid connect inverter will disconnect itself from the circuit due to its anti-idling features. So in these situations, in a backup mode, the loads will only be powered by the battery. Whereas you can remember from my previous slide, in a grid failure situation, the loads will continue to be powered by both the PV and the battery. So that's just one disadvantage. I'll take you through some of the applications that I do see these inverters being used. So in terms of the DC coupled applications, DC coupled inverters, I do see them in new build homes. They are used really good for first-time PV systems and PV refurbishment. So as you can see here, a typical installation circuit diagram with the hybrid inverter connected to a PV array and the lithium ion battery, such as a BYD, which is then connected to the distribution box in the house. So very, very simple, very easy to install In terms of the AC coupled solution, what we see here is the distribution box of the homeowner, and they may have already installed a grid connect inverter maybe 5-10 years ago. So an AC coupled system is very, very neat to add to an existing PV system. So by adding a battery inverter, you will be then able to add battery storage capability to an existing system that has been installed for a number of years. So this is quite neat for systems that are on a feed-in tariff. So in Germany, we have many systems, or many residential systems in Germany which are on a feed-in tariff for 15 to 20 years. So one of the major rule is that if you significantly modify that grid connect PV plant, then you lose your tariff. So a lot of people are leaving their PV plants, receiving the feed-in tariff from these PV plants for the next 10 to 20 years, and then they're adding a battery inverter to add storage capability to that existing power plant. So a battery inverter is very good for retrofit solutions to existing PV plants. But again, if you would like to add to an already existing PV plant, there is no reason why you couldn't also add a DC coupled inverter as well. So that is an option that you also have. So now I'll take you through our product. So because we're in Europe, and because Europe is predominantly a three-phase market, especially in Poland, I will only stick to the three-phase products that we offer at the moment, just so because we don't have much time today. So what I'd like to introduce to you is our ET series inverter for the DC coupled solutions or applications. It is a three-phase high voltage inverter. So high voltage means that this inverter will be able to be connected with high voltage batteries, generally from 180 volts and above. This inverter is available in 4 power classes: 5, 6.5, 8 to 10 kilowatts. It has 2 maximum power point trackers. It has a maximum discharge and charge power capability of 5 to 10 kilowatts. However, that does depend on the inverter size, and it also depends on the battery system voltage and capacity. And one of the main advantages, or one of the unique selling points of our inverter, is that it does have a backup output, and depending on the power class of the inverter, the backup loads can be from 5 to 10 kilowatts. In terms of the standard features that we offer with the ET series inverter, we offer Wi-Fi communication. There is the CAN bus battery communication. All the commissioning is done via the PV Master app, which I will go through in a moment. We do have integrated AC/DC SPDs type 3. However, if you need type 2 or type 1 SPDs, then I would recommend you use external SPDs components, such as from DAN or Phoenix Contact. All the inverters do come with a DC switch. Well, all the inverters that do come to Europe do have an integrated DC switch, and we also include a smart meter for the power control. Optional features is a LAN communication module. So for those systems where the Wi-Fi signal is too weak, then you have the possibility to replace the Wi-Fi module with the LAN module and connect to the router with an Ethernet cable. So in terms of our AC coupled solution, if we're just looking at the three-phase, we have the BT series, which is also available in 4 power classes. It's available in 5, 6, sorry, this is a typo, it should really be 6, 8 and 10 kilowatts. It's also three-phase. It's also compatible with high voltage batteries such as BYD, and it has the same maximum discharge power and backup load capabilities as the ET inverter. So the ET and BT inverter are exactly the same in size, weight, and features. The main difference between the ET and BT inverter is that, if you can remember from my topology slides, is that the BT series does not have any inputs for the PV array. And the standard features is much the same as the ET inverter. So in terms of operational characteristics, we have a wide ambient temperature operating range, so from -25 to +60 degrees. We have a full load operation of 45 degrees, so that means after 45 degrees ambient air temperature, the inverter will start to derate to protect itself from overheating. The inverters are IP65 protected, so that means you can install them indoors or outdoors. However, in Europe, I tend to see most inverters being installed in the cellar or up in the attic or in the garages, so there's no real problems there. For those adventurous seeking adventure, the inverters can be installed up to 4,000 meters without derating. The higher the altitude, the inverter will derate itself as well. The inverters is convection cooled, so they do not have any exhaust fans located on the outside of the inverters, but they do contain a small fan which is generally used to cool down the CPU, just like a normal PC or laptop. So in terms of functions, the main feature that we do see, the main feature that we have for our hybrid inverters and what I do see with other competitor products is the integrated backup function. So we have two AC outputs on the inverter itself. We have the on-grid backup, we have the on-grid output and we have a separate backup output. So the on-grid output is used to connect to the main on-grid loads and provides a point of connection, and it provides a grid reference so that it allows your inverter to synchronize and connect to the grid. And we also have a separate backup output, which allows you to connect your backup loads, which is your essential or critical loads. They could be either like a fridge, a router, a TV, if you consider that as an essential load, or other small loads as well. But just be wary that the backup load does have restrictions on how much power you can connect on each phase. Our backup function, well, it switches into backup mode in less than 10 milliseconds. So we can say that it is UPS level, but we wouldn't say that it's UPS grade. UPS grade means that you have a certificate certifying that it is allowed to be used for medical equipment. I would not recommend that you connect any type of life-saving device or any type of medical equipment to the backup output or use our inverters for these types of applications. In a backup situation, as I mentioned before, with a DC coupled inverter, the loads or the backup loads will be able to be powered from the PV during the day and then from the battery as well if there's not enough power by the PV, or in the evenings as well until the battery is until the battery is empty. When the sun comes back up again, the PV power will then start to produce, and then we'll also then begin to repower the backup loads. And also, if there's enough excess power, it will then feed that power back into the battery bank as well. So in a backup situation, the backup output is 100% unbalanced. So that means each phase will regulate its power in accordance to the power draw of the backup load. So that means that in theory, for example, the backup output could be producing 3 kilowatts on one phase, 1 kilowatt on phase 2, and 1.5 kilowatts or 2 kilowatts on phase 3. So that unbalanced output also does apply to the on-grid output as well. There is a special feature from the PV Master app which you can activate. And for those people or my friends out in the Czech Republic who really need a true zero output, the unbalanced output is the way to go to ensure that you have no electrons flowing out from any of the phases back into the grid. Another unique feature that we have with the ET and BT series is that you can parallel up to 10 ET inverters using our SEC1000S data logger. This means you could have up to 100 to 200 kilowatt peak of PV power, and you can connect up to 10 or 30 battery towers. So imagine connecting 3 BYD battery towers to each ET inverter. And if I think I made the calculation before, if you connected 3 22 kilowatt towers to an ET inverter, that gives you 66 kilowatt hours of battery capacity for one inverter. And if you multiply that by 10, it gives you 66 kilowatt hours of battery capacity. And if you take a 100 kilowatt hour daily load profile, then that gives you at least 6 to 7 days of autonomy. So quite a lot of battery capacity that you can realize using a SEC1000 data logger. other features that we have is the power export limitation. So that's becoming increasingly required in a number of countries now. Czech Republic, of course, Germany, of course, with the 70% rule or the 60% rule. But it really depends on the grid operator these days, and a number of grid operators are now demanding zero export. So you can set the zero export using the PV Master app. What we include with the inverter is a smart meter, which is measuring the import-export at the point of connection. And when it's measuring export, it will regulate the AC output of the inverter to ensure that the export to the grid is zero or as close to zero as possible. In our GoodWe Plus modules, we do take you through more in depth of how the hybrid inverter works and how to set it up, etc. So if you're interested in learning more about the technical details of these inverters, then please feel free to join our GoodWe Plus training modules in the upcoming months. Other features that we have that may be useful is that you can set battery power reservations. So you can manually set how much power you want to reserve, for example, for grid failure. So you can set 50% for usable power. So that means that the inverter will use up to 50% of its capacity for normal operation, and it will reserve 50% of its capacity for the event of a grid failure, for example. And that setting is customizable. You can go 50-50, 20-80, 30-70, 60-40, etc., etc. So what we try to do with our inverters is to have a plug and play concept. So we supply everything in one box. Here you can see everything that is supplied inside the box. As you open it, you'll get the standard wall mounted brackets. You will receive MC4 connectors for the PV input if it is a DC coupled hybrid inverter. If it's a battery inverter, you will not receive the MC4 connectors. However, for both types of inverters, you will receive Phoenix Contact SunClicks connectors for the battery connection, which are very neat. Also, you receive the smart meters. So if it's a three-phase hybrid inverter or battery inverter, you will receive the GM3000, which is the GoodWe three-phase smart meter, which will already come pre-wired with the CTs connected to it, and also an RJ45 connector, which is also connected to the smart meter. We'll also supply with you, if it's not connected already onto the inverter, it will be supplied in the accessory box, which is a Wi-Fi module as well. Again, if you need to, this Wi-Fi module can be swapped with a LAN communication module. The inverters do come pre-wired as well. So that means the BMS or the BMU cable, as BYD like to call it, is already connected to the inverter, and the smart meter cable is already connected to the inverter as well. So I think the smart meter cable is up to 3 to 5 meters length, and the BMS cable is up to 10 meters as well. So should give you enough length to install the inverter. However, if you need longer cables, then you can replace them with a standard Ethernet cable with no issues. Because of the plug and play concept, we did do a number of tests out in headquarters, and we will be doing a number of these kind of installation tests in our European headquarters. But from what we have been told, it can take anywhere up to 22 to 45 minutes to connect and commission the hybrid inverter. So very, very simple, very, very easy. In terms of commissioning and troubleshooting, we do have the PV Master app, which is available for your iOS systems, such as your iPhones or your iPads, and also available for your Android phone. So you can download the PV Master app from the relevant app stores. So as you can see, the PV Master app gives you a nice overview of what's happening real time at the system. It will tell you some high level messages. It can also then drill deeper into the system performance. It can show you the currents and the voltages and the frequencies of the system. And it gives you the options of setting up the export power by using the advanced settings tab. So in the PV Master app, if you download the PV Master app, and if you hold down somewhere on the screen, I think if you hold down the version here, it will take you into a demo version of the app, and then you'll be able to go through and walk through the menus of the PV Master app. In terms of the work modes, we do have 3 unique work modes. We have the general work mode, which is the standard logic of operation. So this is the mode that is used to increase your self-consumption. So that means that the PV power is used to power the loads, then charge the batteries, and then export into the grid. We do have an economical mode, which is generally used for customers who are on a time of use tariff. So this allows you to program, set programmable schedules for charge and discharge regimes into 4 groups. These are repeatable in terms of daily and weekly. As I mentioned, they are ideal for time of use tariffs. So this means that you can charge the battery from the grid at periods of low cost of electricity, so in your off-peak periods, and you can discharge the battery during the peak periods where the cost of electricity is very high. In terms of the backup mode, so the backup mode is basically a mode where the battery will not discharge. The battery will only discharge when it goes into backup mode. So it will not discharge the battery in normal operation. However, in the general mode, although the battery is being discharged and charged frequently, depending on what's happening on the loads and what's happening on the PV panels, in general mode, you can still set the backup function by going into the advanced settings. So even in the general mode, if there's a grid failure, the system will then still be able to continue to power the backup loads. So in terms of the portfolio, we'll go into the monitoring. We do have an online monitoring tool called the SEMS, which stands for the Smart Energy Management System. This gives you a nice overview of what's happening of the PV plant. The data on the PV plant is updated every 5 to 10 minutes. So that means it's not real time, but it does give you a really good overview of the 24-hour period of what's happening in terms of the consumption, the import, export, the state of charge of the battery, how much power is being generated by the PV panels in DC, and how much power is being taken or put back into the battery itself. If you enter the correct address, then you will be able to see a 5-day weather forecast for that particular site. Down on the bottom here gives you a quick overview of what is happening in terms of voltages, currents, power, frequency. Gives you also an idea of what the status is with your battery. So this is gives you a really good point of reference for a remote desktop troubleshooting exercise. In terms of the compatible batteries, I hope Alvaro won't mind, but in terms of the high voltage batteries, we are compatible with a number of different batteries. BYD, which I see is 90% of, which is 90% of the installations that I see personally. We also are compatible with Pylon-Tech, LG Chem in the future, and Alpha DSS. But again, what I do see from the sales figures and from what I hear from installers, it is the ET-BYD combination, which is the high runner combination of products. If you go to our website, www.goodwe.com, you will be able to find our approved battery statement, and that will tell you exactly which batteries are compatible with which type of inverter. So although I didn't show you these inverters in this presentation, we do have a range of single phase inverters, which are the EM and the ES inverters, and the SPB and the BH. As you can see, you can check the batteries which are compatible for them. It is very important that you use the batteries which are on this list. If you use batteries which are not on this list, you will risk voiding the warranty of the inverter itself. So please use the batteries that are on this list as well. So to get to our battery statement, just go into the support section of our GoodWe website, select user manual, select ET, for example, and select the language, and then search by the filter. And then one of the results will be the approved battery statements in English, and you can download that and keep it safe for safekeeping. However, the statement is updated frequently, maybe once every few months. So just check from time to time whether you have the most up-to-date battery statement. So I'll go quickly into what is compatible in terms of the BYD with our ET and BT inverters. So the BYD HVS battery models are compatible with our ET and BT inverters. So from 5.1 up to 12.8 kilowatt hours. If you would like to connect up to 3 towers, you have the possibility of connecting up to 3 HVS battery towers, for example. So if you're connecting 3 5.1 battery towers, and that gives you 15.3 kilowatt hours of capacity. So if you connect the largest HVS tower in the range, so 3 12.8 kilowatt hour capacity batteries, that will give you up to 38.4 kilowatt hours of battery capacity. So quite large, suitable also for small commercial, small, very light industrial systems. But I think maybe Alvaro can correct me later in the webinar, but the HVS, from what I tend to see from the battery capacities, is tailored or targeted for the residential systems. In terms of the BYD HVM, which is the larger of the batteries that HVM have on offer on the high voltage side, we have the 11 to 22.1 kilowatt hour, which is compatible with our battery. However, the 8.3 is not compatible, and that's mostly due to the low voltage of it. I think the voltage is around 160 volts, whereas the ET and BT inverter needs at least 180 volts to be able to operate correctly. However, as an alternative solution, if the customer did want an 8.3 or a sub 8 kilowatt hour battery bank, you do have the alternative solutions using a 7.7 kilowatt hour HVS or a 10.2 kilowatt hour HVS battery as well as a substitute for that, but no real big problem. Again, BYD allows you, and we allow you, to parallel up to 3 battery banks. So if you're paralleling up to 3 22.1 kilowatt hour battery banks, you're getting up to 66.3 kilowatt hours of total battery capacity. So the biggest I know, a residential home, is 2 towers, I think 2 12.1 kilowatt hours. So in summary, again, our inverters are submitted into the German energy storage inspection. So we did it again in 2020. We'll be doing it for 2021, hoping to improve on our score of 90.9%. We do have our UPS level switch time from on-grid to backup with less than 10 milliseconds. We have the economical mode, which you can set the charge and charge, discharge and charge patterns via the PV Master app. It's an all-in-one, so we supply the smart meter. We have export power limitation. By virtue of the smart meter, we can overload the backup for up to 100% for 1 minute, and we also have the unbalanced power supply on both the on-grid and backup side of the inverter. Just the last couple of slides before I move over, before I give the floor to Alvaro. There's some installations that have been done by some of our installation partners around the world. So here's an ET inverter that has been installed in Turkey. Here's a 6 ET inverter system connected to a SEC 1000S. So that's around 60 to 80 kilowatts of PV power, and 6 separate battery banks, one connected to its own ET inverter. And as you can see, for those with eagle eyes, you can see that the SEC 1000S brings a lot of flexibility, and one of the flexibility is being able to connect different batteries at different capacities to each inverter. So as you can see here, this battery has 7 modules, whereas the battery here has 6 battery modules. So you can connect batteries with different capacities to one inverter. You can also connect batteries of different brands. So you can have a Pylontech battery, and you can have a mix. You can have a mix of Pylontech batteries and a mix of BYD batteries, all in one system, all by the virtue of the SEC 1000S, because it treats each individual inverter and each individual system as one complete system. So it manages the state of charge, the charge and discharge of all the batteries to ensure that each battery bank, regardless of its size, is at the same state of charge. The largest system that we know in the world, consisting of ET inverters, is one in Italy, where an installer connected 20 ETs, so they needed to use 2 SEC 1000Ss, and as you can see here, 20 Pylon Tech battery towers. So sorry, Alvaro, I am looking forward to the next 20 ET inverters connected to 20 BYD battery towers. So that's enough from me. I would like to now present or move over to Alvaro, who will take you through the BYD presentation. So thank you for listening to me for the last 40 minutes. So I will hide myself and stop sharing my screen.
Okay. Well, thank you very much, Carlos. Yeah, I'm also looking forward to a 20 ET with a 20 BYD. Though I did really like the previous one. The first time I actually saw one of our systems in parallel. I think was it in Spain, that one?
Yeah, it's in Spain. Yeah, Frutas.
Yep.
Frutas. Yeah. I remember. Yeah. So,
very good. Okay, so I'm going to start sharing my screen.
All right, now hide myself. Great.
Okay. Let me know if you can once you can see it.
Yes, perfect.
Okay. So today I'm going to speak about all the batteries that are compatible with GoodWe. Though I know that we have a focus on the 3-phase, so we're going to speak more about the high voltage batteries. Then I'll briefly speak about the low voltage one, the LVS battery. And if we have a bit of time, I'll show you some sample installations. Okay, so I'll minimize this so I can see the screen well. There you go. Okay, so we cannot talk about the battery box without speaking about BYD, because the company that is behind the product and the chemistry that's inside the battery is really, really critical. Once you understand that in the battery world, scale and the amount of investment in manufacturing and in R&D really is what makes the battery what it is. So first of all, I don't know how well known BYD is in Poland right now, but it tends to be one of those companies that are more in the background than in the forefront. But as you can see in this slide, it's still considered one of the top companies in the renewable energy space, as you see in the left-hand side, as the founder of BYD was selected among the Green 30 for 2020. And also in the overall, as the companies that are changing the world, so we select as number 3 in the Fortune list of the companies that are changing the world. And this is not only due to the innovative concept of creating a world zero emissions, which is the BYD goal, but also technology, manufacturing. So as you see in the bottom, BYD developed and released to the market the Blade battery in the middle of last year, which has started to change the paradigm of EV batteries, starting to shift more of the weight on electric vehicles from the classic high energy density batteries to a safer kind of chemistry that I'll show you later. One of the big reasons why BYD is considered such a pioneer in the field is because from really early on in the sector, they identified that by targeting lower volume but high impact vehicles, like it's in the case of mass transportation or industrial vehicles, converting those ones to an electric powertrain, they could manage to deliver much bigger returns for the environment, reduce carbon emissions a lot more. And this feeds into this vision of BYD of creating a world of zero emissions. In order to be able to create that ecosystem, BYD has to have the products to generate energy cleanly, store it, and use it for transportation. And this also has a relation with the zero waste concept. So So today, all BYD cell factories already have their own recycling facilities to be able to more repurpose and in the end case recycle to extract the materials. And because we believe that it is important to support it's not only a zero energy well, but it should be also a zero waste well. So here in Europe, 100% of the batteries are taken back for free by EFT Systems, and we send them back to our repurposing facilities to use them to fix them or to use them for other purposes, or ultimately whenever they don't have more use, to be sent for recycling. Zero emissions and zero waste are the end goal of BYD, but they understand that in order to achieve that, there's a need to have a control over many aspects of the technology, many aspects of the supply chain that either had not even been developed, or there was no sufficient companies, sufficient presence in the world to be able to deliver that, or there will be risks associated with high cost of elements, etc., as the demand for electric vehicles increases. Therefore, BYD decided to create a fully vertically integrated system where from the raw materials, so BYD is the part owner of all their sources of the elements that they are needed for the batteries, and in the opposite end, when BYD is capable on their own to recycle their own batteries. And now we can go into the product itself. So we've seen the company that is behind it, the technology that is behind it, and one of the things that is very much the identity of BYD is the chemistry inside. So BYD is the world's largest manufacturer of lithium iron phosphate batteries, and actually not only that, if you look at probably the top 10 manufacturers in the world, BYD is the only one that is actually an exclusive LFP manufacturer. The reason why from the very beginning the focus in this chemistry it was for two big reasons. One of them is that it's built with very commonly available elements and non-toxic elements, and the other reason is for its high thermal stability. So thermal stability, the first obvious impact that it has is that it provides a much greater safety. So I'm not going to show you because we only have a short time, but you can find this in YouTube, and when we share with you the presentation afterwards, you can click in this link and see the video where you see the difference in performance when you do a piercing test. Piercing test essentially creates an internal short circuit in a battery. You see how a traditional EV battery, nickel cobalt manganese or nickel cobalt aluminum battery, will burst into flames, whereas a lithium iron phosphate battery, the same battery as we use for the battery box, it actually will heat up a little bit, but it would not, there will be no fire, no explosion. And moreover, the new generation of batteries that BYD has developed, the blades, actually that one only heats up to 60 degrees. So in the video, you can see that it cannot even cook an egg. I mentioned that it was very important to speak about the company before speaking about the product, and it's because in battery manufacturing, scale and the automation in the manufacturing are critical to be able to deliver the necessary level of quality and cost for the product. And that's where we're quite proud that BYD not only has the fully automatic production line for the cells, as it has been for the last 5-6 years since we launched the battery box, but since last year we have a almost fully automatic production line for the packs and the finished batteries, so, which has allowed us to increase enormously the output of the factory. Plus, at the same time, as this is an ISO TS certified production line, to give you an idea, that is an automotive level quality line. then the quality levels have increased also quite greatly. But of course, we can talk about what we think that the impact that this is going to have in your product, what the design is going to have, what the manufacturing is going to have. But we also like showing the real life application. So BYD probably has one of the, if not the company with the most experience, is one of the companies with some of the greater amount of kilometers in the road using the same batteries as you will have in your homes or you provide to your customers. So we have vehicles going over 1 million kilometers with a single set of batteries, and that gives us has given us a lot of information. Has given us a lot of track record to trust that the batteries that we are putting in the battery box are of the highest quality and the longest life possible, or for the longest life possible. And one thing that really is probably the thing that is most part of the identity of the battery box is its flexibility. And the flexibility represents itself in many different ways. The first one, of course, is capacity. So the smallest system there right now is for the 4 kilowatt hours LVS, up to the largest system, the 64 units of the LVL, that is almost a megawatt hour, so 983 kilowatt hours of batteries. So with the same type of installation, the same commissioning system. So when you learn how to install one of them, you will learn how to install all of them. So with a really simple modular off-the-shelf product, you can cover any kind of capacity that your customers might need. The second element of flexibility is the type of application. So you can do single phase, 3-phase, on-grid, off-grid backup with the same kind of battery. And a very important, especially in markets that are now growing and still unclear what the big drivers are going to be. Are the energy prices are going to change? Are there going to be more electric vehicles later on? Well, it is very important to give customers the option to start small, and then anytime later on, even several years down the line, to be able to offer them the possibility to expand the product. The only thing that we mentioned that is important, when you add batteries in series, so that's the high voltage, when you add more batteries to the same tower, these, if the batteries have been running for several years, it is possible that they have lost some capacity. So the new batteries will have the same capacity as the old ones. If you want to make sure that no capacity is lost, it is important to add another tower in parallel. Or in the case of the low voltage system, not a problem at all, because they are always in parallel. And of course, a big element of flexibility is the functionality that the inverters provide. We have just heard from Carlos the incredible functionalities that the GoodWe inverter offers. This is something I believe that we wouldn't have been able to offer on our own. We focus on making the best possible batteries, and we team up with the best possible inverters to give you the functionality and the strength of the combination. The batteries can be installed outdoor, however, because they are IP55. However, take into consideration the IP level, so it requires to be somewhat covered from direct rain, direct sunlight, direct snow, etc. And they can operate between -10 and 50. If the temperature is below -10, which I imagine some parts in Poland right now are already below -10, then the system will not let you do the commissioning. It will not let you work until you're back inside the temperature range. And again, connected with something that Carlos mentioned before, the System Performance Index test. So it is something that's been running since 2018. It compares the ideal performance of our system with the real world performance, the real energy we get out of a combination of a particular inverter or battery. And we're proud to say that we have been #1 for the last 3 years. So 2018 with SMA, 2019 with Coastal, 2020 with Fronius, and who knows, maybe 2021 is with GoodWe. So summarizing, or the battery box. So it is important that you have a strong company behind the product, especially because we are offering 10-year warranties. So you want to make sure that there's a company that will be able to make good of their warranty responsibilities and warranty commitment to you. The second very important part is the lithium iron phosphate chemistry, because this thermostability not only provides you the peace of mind that you have a system that in even the worst case scenario, it is not a health risk for your customers. And on the other hand, it provides longer life because the batteries have a lower internal resistance and they degrade internally less. Then, of course, the flexibility, the fact that you can have the comfort that you can learn how to use one battery. You have a whole portfolio of options. Doesn't matter what you ask your customer needs. Doesn't matter if your customer needs to work on grid, off grid. It's going to be a commercial client. It doesn't matter. You will be able to work with a battery box, and of course, performance. Not only from the quality point of view, but also the highest system performance index in the market. And we now go into the product itself. So the HVS, as Carlos had mentioned, this is compatible with the ET series, with all the high voltage inverters in the GoodWe range, and both HVS and HVM are similar products with slight differences they're very similar in appearance. They are the same in size and weight and so on per module, but they have differences depending based on electrical differences. So the HVS batteries, each of them are 100 volts per module. So you put two of them together to make 200 volts. And then as you add more modules, the voltage of the system will increase. These are direct high voltage system. We've done that to maximize the efficiency of the battery. But this, of course, makes that the voltage of the battery system changes depending on the number of batteries you put in. So just take this into consideration when you put them together with an inverter. So you can have up to 5 of them in series in a single tower. So that's up to 12.8 kilowatt hours. And you can have up to 3 towers in parallel. In the case of the HVM, each battery module is 51 volts. So you start with the smallest system, 150 volts, so three battery modules with a 8.3 kilowatt hours. And the largest system with 8 modules in a single tower, that's 22 kilowatt hours. So it's up to, and then you can have up to 3 of them in parallel, reaching 66 kilowatt hours with a single system. Meaning all these could go with one inverter. Of course, once you put more of those ET inverters in parallel, each of them could have 3 of those towers. Okay. In terms of specs, a couple of very important things to take into consideration. Remember the voltage and remember the current of that you can go per tower. So the HVS accepts up to 25 amps of current, the HVM 50 amps. These you need to look at the same time at the maximum current that goes through the inverter. So I'll show you afterwards an example how to calculate the power of the systems. And a very important factor is that D-rating starts at 5 degrees. Well, actually, there's been improved to decrease to 0 degrees, but at that temperature, it means that the charging power of the batteries need to be decreased. This is a matter of lithium-ion batteries that are low temperature. They need to be protected, so the current that goes through them needs to be reduced to maximize the life of the product. So how to choose between the HVS and HVM? So as mentioned in the first slide, number of batteries tells you the voltage of those systems. So two batteries give you 204 volts, 3 batteries 306, etc. You need to multiply that by the inverter current. In this case, I have put an example of an inverter current of 25 amps. So you by multiplying the voltage by the current, you get in. So with a 5.1 kilowatt hour system, you actually get 5.1 kilowatts of power. With a 7.7 kilowatt hour system, you get 7.7 kilowatts of power. So this allows you to have, in a very small system, very high amount of power. So it's a 1C battery. So this is what I'm describing as a life without hiccups. So you can have small residential systems that, for in the case of backup, so power cuts in Europe in general, they can be normally quite short, but this means that you can power a whole home with this system without having to be too concerned. And the other benefit is that it allows you to start working from a very, very small system. So you can start from a 5.1 kilowatt hours. So for those of your customers that are not clear if storage is for them, if they are not so clear of how much capacity they need, they can start with a very small one and then add capacity later on. That's why the HVS actually has been a very, very popular in battery all over Europe. And the HVM, the same as before, direct high voltage, starting from 153 volts. So the system can start working with three batteries. We multiply that by the 25 amps of this hypothetical inverter, and the 8.3 kilowatt hour system will give you 3.8 kilowatts. 204, it's an 11 kilowatt hour system will give you 5.1 kilowatts of power. So you see that the ratio power to energy is a bit more on the energy side. So the HVM is specially designed for those of your customers that need a greater capacity, or they need to use they're going to be heavier users of their own renewable energy. So they have a large solar array, or they want to make sure that they charge the batteries when it's cheap, and they use that to power an electric vehicle. So it allows them to have a much larger system. And at the same, very important for those of them that don't know if later on they probably would add an electric vehicle, they would add a heat pump or some other high energy consuming devices. They can start with a medium-sized HVM and then later on add a lot more capacity to it. Same as well, as Carlos mentioned, very important is the compatibility list. In the compatibility list, you can see exactly which models of inverter are compatible with which models of battery. I'm going to, let's see if I can get, I wanted to show you in the Zoom, but anyway, as you can see here on the left-hand side, in the section related to GoodWe, you see that most of the combinations of battery inverters are compatible. However, take into consideration that a couple of the combinations are not available. For example, for the three-phase systems, you can see that the smallest of the HVMs, because the voltage is much lower, so it's 150 volts for the smallest one, those ones are not compatible. And in the case of the single-phase systems, the HVS, as the largest one, is 500 volts nominal. This is not compatible with the single-phase inverters. Okay, we go into the actual installation steps. So the first thing that is quite characteristic of the battery box is the fact that the battery modules are put together without any cables in between. These we have Carlos mentioned before that the inverter installation can be done in 22 to 45 minutes. Well, this will continue making the installation quite quick. We estimate that regardless of the weight of the modules and the packing and unpacking, it would take you about half an hour to do the full assembly, including the connections, and then afterwards you just need to do the commissioning. But first we start assembling the pieces and make sure that you are attaching the battery to the wall, because especially the large HVM systems, they can be quite slender and quite tall, so it's very important that they are attached to the wall. When you are buying the product and when you receive the boxes, you already have on the boxes a clear differentiation between HVS and HVM. However, Please make sure that you are not assembling them together. So HVS and HVM cannot be put together. You cannot have a mix in a single tower. Of course, because you're putting different batteries with different amp hours, different voltages, so the system wouldn't work. And an easy way to confirm that that hasn't happened is by looking at the bottom left-hand side, because 1 bar would be an HVS, 2 bars would be an HVM. And then one of the new things we have added to the premium batteries is the single point of connection. So we wanted to make it really easy for the installer to know exactly where to do all the connections, plus at the same time, make sure that they're always operating the system safely. So there is only a possibility to switch on the battery when the cover is closed. So as soon as you open the cover, there will not be any live voltage in the battery system. Furthermore, once you open the cover, you'll have just one place where you need to focus for your installation. So you'll have a section for grounding, you have a whole section for communication, and you have a separate section for power connections. The first step always is to put the grounding. The second step would be the communication, and in the GoodWe&BYD, the cable comes pre-assembled already in a RJ45 format, so you can just plug it right in. So that's it. That's no complication in the communication connection. But if you have any issues with the RJ45, you have a second option that you could use at the 8-pin on the top. So for each inverter, you have the possibility of using RJ45 or using the 8-pin. And very important, the internet connection. So the internet connection is recommended for everyone. It's not compulsory, but it's very recommendable because this can save you a lot of trips. This can say every system that requires an update, it can be updated automatically from the server. If you have an issue or the system has shut down for any reason, you can send us you can open a ticket to us, and with that information, we can go inside your battery and confirm the reason why it got shut down or it had an alarm. So it can be fixed remotely in many cases, or in some other cases we just be able to pinpoint exactly which component needs to be replaced. So then the service part gets taken care of quite easily. And the final step is the power connection. So you just need to have the cables with sufficient conducting open, and then you go right in and you clip it close. So once again, you don't need to have additional components. You don't need to have any screws in there, any terminals in there. And once you close it and it's safely closed, then you can switch on the system. There is a sensor in there that it will make the battery shut down immediately if the cover is open. For parallel connections, you don't need additional components again. So of course you need a bus bar to make sure that every cable is the same. And you can also use a fuse box if you prefer. But in general, you don't need any additional component from our side. You just need to make sure that there is a communication line going to the master battery, and there is communication going from the master to each of the slaves. So we'll go in series from battery 1, we'll go to battery 2 to go to battery 3. And in the whole installation, the only thing that's slightly different, one of the dip switches, the one in the middle battery. So if you have 2 batteries, you don't need to do anything. If you have 3 batteries, the middle one, you will need to change the bottom dip switch. This is because this is it's a terminator, it's a communication terminator. So you need to make sure that you're opening the communication terminator so it doesn't stop the communication between batteries. Okay, and the final step is the commissioning. So in order to, this very, very, very important to follow the right steps, because if not, the battery will not finish the commissioning process. The first thing is to switch on the battery. The inverter should not be on when you switch on the battery. So switch on the battery, do the commissioning. Once the batteries have finished the commission and they are essentially waiting for the inverter, then you can switch on the inverter and then set up the inverter using the PV master. Then it should be ready to use. If you do the other way around, you will essentially see that the battery cannot finish the commissioning process. It will give you an error. So in order to do commissioning, you can use both an app or a computer program. So the app is both in Android and Apple, so in iOS, and it's called the BConnect. So it's the BYD battery box BConnect. You have the QR codes here. You have the QR codes also in the manuals in the product. So it will be really easy to find when you need it. The only thing we recommend is that you download the latest firmware before you go to site. This is because sometimes you might not have the best internet when you're down in a basement or in the place that a battery will be installed. So make sure before going to site to download the battery firmware. And also very important to do this every time, because there might have been an update from the last installation you did to this new installation. So make sure it just takes a second, download the latest firmware. So when you get to site, you can connect to the battery Wi-Fi and update the battery. And once it's been updated, the commissioning process is just 4 steps. Confirm the time, select the type of battery that you are installing, select the inverter brand that you are using, and finally select if it's on-grid, off-grid, and single phase, 3-phase. Once it has been commissioned, or well, even if it has not been commissioned, you will notice in the top left-hand side an LED. There's a place where you press the button to switch on, switch off the system. This LED will give you some indications, confirm if the battery is working normally, if the battery is waiting for the inverter, if the battery is there's a low state of charge. That's a lot of information that the LED will provide you. And this is in the manuals explained what each of the signals mean. And this actually, if there is an error, there are 16 different codes that will tell you exactly where the error is. If you have a doubt, you can use also the BConnect Plus, which is in the EFT Systems website to get the read of any errors. And as a final step, so when you extend a high voltage system, or if you had an issue and you had to replace one of the modules, take into account that the batteries, when they come from the factory, they come at 30%. And these are batteries that are connected in series. So in order to allow them to balance each other and be able to charge and discharge at the same rate and be all at the same state of charge, you need to add the new battery when the old system is already at 30%. So you either need to set the inverter to, if the batteries are low, you need to set the inverter to charge to 30%, or if the batteries are a higher state of charge, then you need to discharge them and stop at 30%. That will make the extension process the smoothest. And this is it from the high voltage point of view. And as we still have quite a bit of time, I think I want to show you the LVS installation, which you will notice that the LVS is very, very similar to the high voltage. We're using this universal framework, universal format of the battery. So you're more familiar with it, and also you can benefit from the economies of scale of building all the same design of products and future-proof this design. So these battery starts from 4 kilowatt hours. That's a single module with 4 kilowatt hours. And by putting them in parallel, you can have up to 64 modules in parallel, allowing to have 256 kilowatt hours in a single system, as you can see here. And this unit derates also at 5 degrees. One of the first things that are slightly different from the high voltage and the low voltage is, as you can have so many modules in parallel, we prefer to offer you a possibility of having the communication module outside. So that's the BMU. So you just need one BMU per system. So you can have 64 batteries with just one of the BMUs. And this is the one that would be interfacing with the inverter. But then each tower will have a power distribution unit. This is where the protections are and where this acts as a combiner box internally for the 4 modules. You can parallel in towers of 4 modules each. There is just one exception. In the case that you just have one tower, that one tower could have up to 6 modules. Another feature that we have added in this premium LBS, again, to continue making the installation as easy as possible, are these dedicated installation area. And that includes on the left-hand side these special connectors that I will show you later how they are assembled. So the first step is will be the grounding and then the communication. And then we get to the connectors. So in the future, we would offer you the possibility of buying pre-made cables. But for now, you just have this simple process that you just need to have a hydraulic crimping tool or like a manual crimping tool that just squeezes the connectors on the cable. So once you could prepare this in advance, so when you get to site, it will be in a second. You just clip the connectors right in, and from this it will go to the power on the DC side or the battery side on the inverter. When you parallel them, the only thing to take, the 2 important things to take into consideration is, as usual, make sure the cables are the same section, same length for each of the batteries, and that at the end of the communication path, so from the master battery, the out will go to the in of the first slave, and from the out with the in of the second slave. Make sure to put a terminator, a CAN terminator that is provided with the product at the end of the line. So the switch on and off procedure is slightly different. So the BMU doesn't have its own power. The BMU is powered by the batteries. So in order to switch on the system, you just need to press on one of the batteries. That one battery will power the BMU, and it will power all the rest of the batteries that are communicating with that first battery. Once you have done the commissioning, then you can switch on the inverter. For switch off, it's similar, but you can use the BMU to switch off all the batteries. So just by pressing 5 seconds on the BMU, it will switch off all the batteries that are connected to it. For extension of LBS modules, these ones are in parallel. You don't need to follow strictly the state of charge. It will be able to, the different BMSs, because each battery has its own BMS, they will know each other's state of charge, and they will try to balance each other, especially as they function. However, if the state of charge
All right, I think Alvaro has just disappeared for a moment. We'll just give him a couple of minutes because this is to give him the chance to log back in. Alicia, can you hear me?
Yes, I can hear you. So I suppose this is from Alvaro's side. Let's wait for a couple of minutes.
Let's show a bit of patience and give Alvaro the chance to get back in. It did happen right in the beginning, so it didn't take too long for him to get back in. Well, I did want to say at the end of the webinar, but I'll say it now. In terms of the installation of the BYDs, I did have the pleasure of installing the old battery box in 2019 for the SPI tests. And I'm not such a big man myself, but I did manage, with the help of a TUV colleague, to install to put together the battery module within half an hour. I think most of the time was unloading and unpacking the boxes, but the whole process of stacking the modules and making sure that the connections were in place was quite easy. So you can take it from me that it's very easy to install. And EFT does have a big repository of nice after-sales documents which are available from the EFT Systems website. You can download the latest firmware and keep that on your laptop. You can download a number of troubleshooting and installation checklists from their website as well for all the batteries, HVM, HVS, LVS, etc. In many different languages. I really like the troubleshooting document, which takes you through a very, very exhaustive range of troubleshooting procedures that you can do in case you're having trouble installing your PV. Yeah, in case you're having trouble installing your BYD battery. So let's. Yeah, it's one of the reasons why we prefer face-to-face trainings, so that we don't have any issues with the internet connections. So hopefully once the pandemic is over, we can get out on the road and meet you all personally, especially my friends in Poland, and do face-to-face trainings, perhaps with Alvaro, and do some hands-on training, bringing us some batteries with us and our inverters as well. Perhaps I go through some questions that were in the Q&A session, which I found interesting. One is a very frequently asked question regarding off-grid applications. Unfortunately, I will have to disappoint you and say no, our ET or BT inverters or any hybrid inverters that we have on our range are not suitable for strict off-grid situations. So if there is no grid connection, please do not use our inverters. So you can, another interesting question that we do receive a lot is whether you can use the ET inverters without a battery. The answer is yes. In this case, the ET inverter will operate as a standard grid connect inverter. So this means that the ET inverter will turn on in the morning when the PV starts generating power, and will turn off when there's not enough sunlight to generate power, and then repeat itself for every day of the week. However, if you would like to use the backup mode, you do need the battery. That is necessary to ensure that you have reliable operation during a grid failure. So the backup, there's another question in regards to how long the backup, the system can work in backup mode. So that really depends on the time of the day that the grid failure happens, and also how much battery capacity you have. Hi, there's Alvaro.
Hi.
Jack.
Sorry for that. Maybe it's too popular of a webinar. Too many people.
Too much bandwidth being taken up by everyone. No, that's all right. I was just doing some juggling. I was just doing some magic tricks. I'll mute myself.
I hope you had a long repertoire of things to fill up time.
Thought you went on a siesta, but that's okay.
I was mentioning about the extension for low voltage modules. This is less critical than for the high voltage modules, because these are in parallel. But it is recommendable because it takes a shorter time to balance the whole system if they are a closer state of charge. And I'm glad I could reconnect, because there's one section I always want to tell everyone about. And if there's one thing that I want you to leave the presentation with, is with the section I'm going to speak about right now. And it's the service and support, because all the information you need, because you will forget probably a lot of the stuff that we have presented here today. You probably will go to site and you'll have to remember, or you have to go back to documents that will remind you of the specific steps. In this section, you have everything you need to install the product properly, and in case you have a doubt, where to check, and in case you have a problem, what to do. So first, very important, is the EFT Systems website has everything. So remember the eftsystems.de website. Right now, it's German, English, French, Spanish, and Italian. For premium, mostly focused in German and English. So in the English section, you'll have all the latest downloads. You'll have all the programs, you have firmware, all the special documents. And one of the documents I want to draw your attention to is the service guidelines. The service guidelines even though it is focused on service, it does help you check that you've done everything correctly. So the first section of it helps you go through your installation and make sure, as I check step by step as a checklist. So the things that that you should check before leaving the site. So this is working, it's doing charging, it's doing discharging. So you take a few measurements. So once
Oh, Alvaro, the sound's gone. Oh, it's happened again. I will start perhaps singing. Let me just send a message quickly to Alvaro.
Seems this is trouble with the sound, because we still can see his presentation, so he's in.
Yeah, he's still in. Okay, he's out now. We are very, 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 very sorry. So if we can just give him a few moments to log in. We are here till 11 o'clock, so we still have 20 minutes, but we are flexible. Yeah, which was a shame, because Alvaro was going through a very, very important part of his presentation. So maybe I'll just jump in now, share with you my screen. I think this is what Alvaro was wanting to show you. If you go to the EFT Systems website, so that is EFT-systems.de. They do have an English version or up to 6 languages. Go to the download section here in the top right-hand corner, and you can scroll down. And as Alvaro was mentioning, you can find a lot of information in case you have forgotten some of the information in today's webinar. For example, you can download the latest HVS, HVM firmware. You can download the data sheets, the operating manuals, and what I found particularly useful is this service guideline and checklist, because it will go through a number of checks that you can go through. Very, very useful document for troubleshooting. Tells you, has a lot of invaluable tips there to be able to get your system online. Yeah, this documents in Italian. I'm not sure. Maybe we'll get Polish there in at one stage, but that's. Okay, so let's see. Perhaps I'll just keep going through some questions. Okay, so we have Alvaro trying to connect. So I'll do some more magic tricks at the moment. I'll go through the Q&As to see whether there are any questions which. Yeah, so there was one question on how long the inverter can work in backup mode. So that really depends on how much PV power is generated during the day and how much battery storage you have. Of course, if there's no sun and if the batteries are empty, then the inverter will not be able to continue to power your backup loads. Is it possible to connect batteries from a third-party manufacturer? The answer is no. Only the batteries that are on our approved battery statements are allowed to be connected to the inverter. Connecting other battery manufacturers will void the inverter warranty. The PV Master app is available in 6 languages. Unfortunately, not yet available in Polish, but that is a language that we're working on. And if there are other languages that you require, we will look to add them on as well. Another interesting question regarding the unbalanced load restrictions. So each phase of the ET inverter can produce from 0 to 3.3 kVA. So that is for the grid output and also for the backup output. So when you're connecting loads to the backup output, please ensure that the loads that are connected are less than 3.3 kVA in power across on each phase. Another interesting question that we get quite a lot is in regards to whether you're able to connect your entire house to the backup output. In theory, technically, yes, it is possible. However, I would avoid doing that. It is not intended, the backup output is not intended to connect your entire house load to it. Simply because if you did, if the inverter, for example, shut down, then you will not have power to your loads at all. And of course, I wouldn't recommend it because perhaps you will be exceeding the 3.3 kVA per phase limit on each of the phases. So the BMU or especially the BMU, especially for the BYD high voltage batteries, they are supplied with each battery tower. So you will, from your distributor, order 3 or 4 or 5 modules, however many you want, and then they will also supply you with the BMU module as well. So yes, the BMU is required for each battery tower, for the high voltage batteries at least, so that you can achieve the master and slave connections. In regards to surge protection, earthing, and lightning for the battery, perhaps I'll leave that to Alvaro when he joins us to perhaps answer that question. And I think I answered that as well. Okay. What I found interesting in Alvaro's presentation is the necessity, forgetting my English now, of ensuring that the battery bank is at 30% state of charge when introducing a new battery into the tower. So you can use the economical mode to charge or discharge the battery to the tower to 30%, and then you will then be able to insert the new tower. So when you insert the new tower, I would assume that you would have to go back into the B-Connect app and set the battery tower module number. So you would have to increase the quantity by 1, and then also download the latest firmware onto that battery module. And once you've done that, then you would have to go back into the PV Master app to do the basic commissioning and select the BYD module battery with the correct number of modules as well. So that's probably something to keep in mind of. Okay, Alvaro is there. Great, great.
Okay, I see you.
Oh, sorry. Let me stop this. Okay, I'm going to try to do it really quickly. I'm having an issue connecting to the China server of Zoom. Don't know why. So I'll try to do the support section really quickly and then get back to you. Okay, I'll share my screen. Okay. Yeah. So as I was saying, the service guidelines gives you some advice on what to check even in a regular installation. And when you have an issue, it tells you what steps to follow to check if you have had this particular error code, what to do. And then in the worst case scenario, at the end of the document, it tells you who to contact if you're having a problem and you're still on site, or you're having a problem but you're already back in the office. And when you are on site, we have this BConnect Plus. BConnect Plus allows you to connect by just simply connecting to the battery Wi-Fi. You'll be able to actually have an additional way of commissioning the battery, which is really quick down in here in configuration. But also it has several functions to go in depth inside the battery, be able to check the different battery voltages, the error codes, all the history. You'll be able to download all the history of the function of the battery. So a reminder, one of the big pillars of service, remember to connect the battery. Even if your inverter is already connected to the internet, the battery needs its own internet connection to connect to our server, so we can remotely access. This is not for additional monitoring. This is just purely for service. So in the case of having an issue, we will be able to connect and help you solve the issue. And very, 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 very important, every service case is handled with our ticketing system. So make sure to get an account. And in that account, you'll be able to register systems. And then in each system, register a ticket. We'll use that for all the service calls and the replacement. But as an added bonus to it, we have the B Partner program. So these are loyalty program where you'll be able to get get benefits, get additional support. You be able to have a shop to use your points in exchange for parts, marketing materials, etc. And you get points just simply by registering the serial numbers of the batteries you install. So then you just need to register your batteries. And either open a ticket there, or when you call us on the phone, say my system ID is blah, blah, blah. And I have this case, so we can open a ticket for you. This is it from a service point of view. I had an additional section if we had time. I know that we have been struggling with my connection. So I would say we'll give it a go. And if the connection stays.
Yeah, give it a go.
Yeah, so we give it a go, and if your connection stays fantastic, if not, I think we can jump into the questions. I don't want you to be suffering any more of this back and forth. Okay, so I have this section a bit as an inspiration, so just give you ideas of the different uses that the batteries can be for. So can have from single phase residential, 3-phase residential. So you're using the LVS on the left hand side, is the HVS on the right hand side, and other kind of residential off-grid or backup. This is a nice resort up in the Caribbean, so it's quite common to now find lithium batteries in off-grid applications as they're providing a lot longer life, higher efficiency products, and a lot less maintenance. So in its whole lifespan, it actually ends up having a better price per lifetime kilowatt hours than would be a traditional lead acid or gel batteries, etc. And of course, commercial. So we have this case. There's a very interesting case in Belgium. It was actually we are posting about this in. We just posted about it in our social media. It's a farm in Belgium that was connected to the grid. They were expanding really rapidly, so they got asked by they got told by the electricity grid that they had to upgrade to medium voltage, which would be a massive investment to actually still pay the same or even more for electricity. So they decided to invest the same amount of money to actually become essentially off-grid. So they have a wind turbine, they have solar, and then in combination with that, they are essentially consuming, they no need for the grid at all. And another typical scenario that we're observing more and more in Europe is a community of neighbors wants to add EV chargers to the site, and then they get an information from the local distribution network that yes, you can do it, but you need to pay to upgrade the substation or they upgrade the transformer, and this is a really high cost. So they say, okay, can we use the same amount of cost, the same investment to actually provide and give ourselves some kind of peak shaving system? And that's what they did. This was a community in Germany that they decided to use the same investment that they were going to put to the network to actually use internally the power that was generated by themselves, and they had set up a bit like a peak shaving system. And this is a problem that we're observing everywhere, even here in the UK. There is actually proactively the distribution networks are telling you, don't even ask for approval. Consider that there's going to be a high cost just to be able to connect. You still need to pay for the power. You still need to pay for the energy, but just remember that you're going to have to pay just purely to connect. So taking this into consideration and possibly try to find some peak shaving solution. And other typical application we're seeing more and more is it's microgrids, also large off-grid installations that they can actually, you can have a business, you can have a school, you're gonna have a hospital that is being powered by the batteries, and then this is actually at the same time powering the nearby town, the nearby village, using the excess of power or even some kind of pay-as-you-go arrangement between them. And of course, anything you can think of. At the end of the day, batteries are flexibility. So then they're clean. They provide you a possibility to provide clean energy. So we have examples of these off-grid bar on the left-hand side. We have in the top right-hand side systems used for no fumes construction. So these can be used for tunnels, can be used for underground construction, can be used for music festivals. And the bottom side, for example, you have this is a military product. So they're used for having some lights and to power some camps, which are quite light devices. So they'll be carried with them. These were at that time 2.5 kilowatt hour modules. So each of those boxes is a self-contained 2.5 kilowatt hour battery that can with its own inverter, and that can be used to power some lights and the camp, the heat, a bit of a heating, etc. And that's it. We've managed to finish it before the internet kicked me out again. So probably we're gonna have a few minutes for questions.
Yes, thanks, Alvaro. Thanks for going through your presentation. I think it's one of the first for me. I think it's the first time I've actually gone through one of the BYD. So I've learned a lot, especially about the 30% rule when you're adding modules.
Yeah, especially critical in high voltage, especially critical in high voltage.
Yeah, so I did mention to the audience that to get it to 30%, you can use the PV Master app to discharge to 30% or charge to 30% if you're going from the other way. I did answer a lot of the questions while you're away, but there was one question which had me perplexed. And this is a question by Sham. It says, so with the battery, such as the high voltage ones being at such a high voltage, do you have any recommendations for earthing, for earthing, lightning, and surge protection? So for the inverters, I do recommend type 2, or if for lightning, direct lightning strikes type 1. But yeah, I have no idea when it comes to battery systems.
So we have the grounding for the housing of the, this is recommended in the installation, and we actually recommend also the type of section of cable you want. That's in the operating manual. We actually don't have specific for lightning. At the end of the day, the batteries are not connected externally, so the lightning will always pass by the inverter. It's a lot more common that lightning damages the inverter than damages the batteries.
Okay. Okay, great. So then it's all on me then. So I would recommend, I guess typical PV design methodology is research the density of lightning strikes in your region. If it's below a certain threshold, then I think you are able to get away with type 2 surge protection. But if you're in an area which has a higher density of lightning strikes per certain number, then I would recommend a type 1 surge protection on both the AC and DC. And it also depends on whether the existing structure that you're installing the PV panels on does have lightning protection. So if it has lightning protection, then most likely you will also need to include type 1 protection on the inverter itself. So you can use components such as Phoenix Contact or DE and H for those types of protection. I think I answered most of them. Most of the questions were relating to the inverter operation itself. So there doesn't look to be any other questions regarding the battery as well. So I think we can end the webinar here. I'll stay on for another 5 minutes in case someone wants to have a chat. But thank you once again, Alvaro. It was very, very nice to have you join us as part of our push to promote energy storage systems, particularly in Europe, in Poland, in Germany. It's happening everywhere, and I think we're in a time where the next revolution is happening. So it's great to be in.
Yeah,
in Europe.
I think it's surprising all of us, and we believed in it from the beginning. That's why we said this product app we created about 6 years ago now. But we didn't expect it to take off that quickly, and 2020 definitely with I think a different change of mindset, people spending more time at home, focusing on their home and focusing on what they can do for the environment. I think it has been a big push, and it has really catapulted the sector to another level. And it's the moment we're talking all about these green recovery. So a lot of countries are pushing for that green recovery. It's generating a lot of jobs, not only on manufacturing the products, but also on installing them. So we see the subsidies that happen in Northern Europe, the changes in the net metering in Belgium. And I hear that something might be happening also in Poland. Is that right?
Yeah, well, there's always talk. The government apparently has announced the extension or a new program to the Mój Prąd program that they had over the last 3 years, which has really accelerated the growth of PV systems. But until now, like most government announcements, it does take time for them to finalize the details. But like you said, I do see in Europe a lot of subsidies being made, being offered to homeowners. In Germany, for example, different states are offering different levels of subsidies. There is an EV charger subsidy now happening in Germany as well. So we are witnessing the start of a revolution, and it only just needs to happen in one country, and then it will start transferring into other regions as well. So
yeah, exactly. Electrically is a must. now with the higher penetration of renewables and the uptake of EVs, governments in support of their national grids, they actually need to support storage as part of the equation, because if not, they're going to continue struggling. They're going to continue now curtailing wind, curtailing solar. We've seen these cases easily in California, and probably you have more anecdotes in Australia, even with times that the full grid was, I think South Australia was powering fully on solar,
Yes.
home solar sometimes. That's
Yeah, exactly.
Crazy. Yeah,
exactly. And I think one of the interesting concepts that are coming out now is the concept of virtual power plants. So aggregating a lot of individual residential systems with battery storage. That's also going to be another trend I see in the future as well. So maybe it's something for some of our participants to get into. And, you know, having high quality systems within high quality components within a virtual power plant, I think is a must to ensure the reliability of the energy supply at that level as well. So partnering with BYD and GoodWe gives you
you have the SEMS that has it's the first step to start connecting to a large virtual power plant. At least it has the technology behind it that you can communicate with.
Exactly. Exactly. I had one question for you. It's in regards to your low voltage and the high voltage batteries. Is there a key decision challenge? What would make you go for a low voltage as opposed to a high voltage battery, and what would make you go to for a high voltage battery and a low voltage battery?
So the storage world tended to come from low voltage. It tended to be 12 volt, 24, 48. So most of the storage inverters have been in that space. So we also started in developing batteries from the very beginning to that space. But in order to support PV systems that normally work at the hundreds of volts, then the high voltage systems were created. The high voltage system works at a high efficiency because you have less transformation going between the solar and the batteries, and also it tends to be cheaper because all the components are smaller, less transformers, etc. So in general, the industry is when there's PV and it's a home PV system tends to move towards high voltage because of those factors, but you still will have inverters that are low voltage, customers that don't want to work with high voltage because the regulation changes above 100 volts DC. You now go into the low voltage directive, whereas below 100 volts is the ultra low voltage. So you need a lot less protections. You have a lot less safety hazards that you need to take into consideration. So it's like you might want to have the peace of mind of working with a low voltage system, or you might want to just work a bit more on the design side and work on a high voltage system because you're going to get a greater efficiency.
Okay. Do you still see low voltage batteries being used more often in these microgrid applications like that you showed in one of your presentations? Or? So
I see low voltage. I see it more and more being the share of the sales of low voltage tend to be more and more on the off-grid side.
Off-grid side.
Or on very, very large systems, because with our low voltage systems, you can reach up to close to megawatt hour. So for a commercial large size, we use in low voltage. But we expect the on-grid commercial systems to be replaced by the commercial battery box. And going forward, which is also compatible with your inverter or your power conversion system. But in the meantime, I think we'll see low voltage for large capacity systems and off-grid mostly.
Oh, great. Yeah, we're also developing some larger hybrid inverters, some 50 to 200 kilowatt DC coupled and AC coupled inverters as well. But they won't be ready till maybe next year or so. But yeah, I guess the trend is getting bigger and bigger. The regulations in Germany are changing. So before, I think there was a 10 kilowatt limit for a residential system that has been now lifted to 20 or 30 kilowatts. So we need
I don't know who needs that at home, but
you'd be surprised. You'd be surprised. There are a lot of people, in this energy storage story. I guess there are a number of people, quite surprisingly, is that they don't really care about the upfront capital costs of the the system, all they really care about is just being independent from the grid. They want to be as independent as possible. There's something about being independent which really captures people, regardless of the cost.
I have seen that quite a few times, and it's like, yes, the investment cost doesn't matter. There's a lot of anger at some electricity companies in some countries. There's a feeling that they've taken advantage of that position that they had. The customer was essentially captive. So as soon as they've had the technology to get away, they've done it. I wouldn't recommend the regular customer to do that, because financially speaking, when you have the grid, it's hard to replace it. When you have a generator, it's really easy to replace a generator by renewables. It's a lot cheaper. So probably 4 to 5 times cheaper. Yep. But grid compare with a battery, I think you need to size the system so you use it almost to 100%.
Okay. Do you have batteries which are specifically tailored for these PV diesel microgrids? Can we use the HVS or HVM batteries, or do you have another range which are more suitable?
It's more common to see low voltage, but it really depends on the inverter. If an inverter has a generator input, yes, you can use a high voltage, but normally high voltage systems are a bit more specific for grid connected applications. But yeah, we have, I mean, does the ES have a generator input?
No, we don't have any generator inputs. Okay. No. That's another question we're gonna ask. Can you connect the generator to our inverters? And the answer is unfortunately no. So yeah.
Okay.
All right. Well, I don't have any more questions here on the screen. I don't have any other personal questions either. So we can end the webinar now. So again, thanks Alvaro for joining. Thanks Aricia as well for actually creating the magic in the background there and being patient. I'm sure she must be getting tired of listening to me saying the same things over and over again every month. But thank you. So yes, thanks for everyone for attending, and we hope to provide more regular webinars, showing you more topics, more different components, more interesting, more new products as we move into the future. And I'm sure BYD will surprise us in the future with some new products. And so it'd be nice to keep our finger on the pulse in that respect. So thanks, Alvaro. Really good to have you join us for the first time. So good to see you again soon. Thanks, everyone.
See you soon.
Do widzenia.
Thank you, everyone. And yeah, let's hope that in the near future, we will, during our face-to-face trainings, will not have these kind of technical issues. So thank you, everyone, for your patience and your time today. Just one thing, that in these situations, we can see that this webinar was going live. It's not recording, it's not recorded, it's really live. So thanks, everyone. And we hope to see you very soon.
Very soon. Thanks, everyone.
Carlos.
Have a good Thursday. Thanks, Aricia. Bye-bye.
Bye.